The lesson objective for this video, students will use inverse trig ratios to find missing angle measures. So first of all, what is the tangent ratio for angle A? We already know how to find the ratio when we're given sides, and in this case we're given the opposite and the adjacent here. So the tangent of angle A would equal 15 over 20, which we usually reduce to 3/4. So if I want to know what the angle is, I'm wondering, okay, well, what angle has a tangent of 3/4? And so we use what's called the inverse tangent. So that's written with a little -1. So I want to know what is the inverse tangent of 3/4. And that will give me the measure of angle A. So in essence, they switch places, and then you just make it the inverse. So you just put that in your calculator. You're going to use your shift or your second button, and you'll find it right above the tangent on the keypad. So I'm going to take the inverse tangent of 3 divided by 4, and I get 36.86, so 36.9 degrees. So the measure of angle A is approximately 36.9 degrees. And so here's another one. Find the measure of angle C to the nearest tenth. So first of all, how would you set up the tangent of C? We have the opposite and the adjacent for angle C. So the tangent of C is 20 over 16. So the inverse tangent of 20 over 16 is going to equal the measure of angle C. Again, all you're doing is it's like they're switching places, and you're taking the inverse. So you don't actually have to reduce the fraction when you're putting it into your calculator, since the calculator will do the division for you. So if you put it in, the inverse tangent of 20 over 16, you get that the measure of angle C is approximately 51.3 degrees. Okay, now it's not always going to be tangent. It can be inverse cosine or inverse sine. So let's set one up here. We've got A, B, and C. And this time AB is going to be 12 and AC is 15. And again, we want to find the measure of angle C. So now if I look at it relative to angle C, I've got the opposite and the hypotenuse. So since I have the opposite and the hypotenuse, I would be using the sine. So the sine of C would be 12 over 15. So the inverse sine of 12 over 15 would give me the measure of angle C. And so if you put that in your calculator, it comes out to 53.1. All right. For example 2, you're going to have some problems similar to this in your homework. Let angle A and B be the acute angles of two right triangles. Use a calculator to approximate the measures of angle A and angle B to the nearest tenth of a degree. So all you're doing is you're putting this into your calculator, and we want our answer to the nearest tenth. So for example A, you're just going to put and switch places and do the inverse. So you're going to take the inverse of 0.76, just punch that in your calculator, and you should get that the measure of angle A is 49.5 degrees, approximately. So these are just really straightforward. You're just using your calculator. If the cosine of b is 0.17, what angle has a cosine of 0.17? We're taking the inverse cosine. And so when you plug that in, it comes out to approximately 80.2 degrees. So on your own, go ahead and figure out the measure of angle D to the nearest tenth if the tangent of D is 0.48. Alright, so in your calculator, you should have hit your shift button or your second button, depending on which one your calculator has. And then the tangent -1 is written above it, above the regular tangent. And then you just put in 0.48 and hit your equals. And you should have gotten 25.6 degrees. So when we're solving right triangles, what that means is we are going to find all the sides and all the angles. So when you're missing sides, we have 3 different tools we can use to find the missing sides. The first one we learned, and you've known it for a long time, but sometimes forget, is the Pythagorean theorem. If you've got 2 sides, you just use the Pythagorean theorem to find the third side. If you've got special right triangles, you can use your rules for special right triangles to find missing sides. And if you're just given a side and an angle, you can use sine, cosine, and tangent, your trig ratios. If you're missing angles, that is when you're going to use your inverse trig ratios. So sine -1, cosine -1, tangent -1 is how it's written. Okay. So for missing sides, use either the Pythagorean theorem, special right triangles, or sine, cosine, and tangent. And then for missing angles, use your inverse trig ratios. So here we have an example. Oops. There we go. All right, so we're going to solve the right triangle and round the decimal answers to the nearest tenth. So we're not really concerned about the drawing. We're just going to look at the triangle here. Okay, so what they've given us so far is they gave us one angle, 23 degrees, and they gave us the right angle of 90. So already I know the measure of angle A is 23, and the measure of angle C is 90 degrees. And so since a triangle has to add up to 180 degrees, I can figure out that the measure of angle B has to be 67 degrees. So we've got all of our angles for the triangle there. Now I'm missing AC and BC, so I'll go ahead and call AC X here. And that is adjacent, and 40 is the hypotenuse. So when I have the adjacent and the hypotenuse, I'm going to use cosine. So the cosine of 23 is x over 40. So if you multiply both sides times 40, x is 40 times the cosine of 23. And that comes out to approximately 36.8. And that would be feet. And then if I let BC be y, that is my opposite. So I've got my opposite in hypotenuse, so I'll use the sine to find y. The sine of 23 is y over 40. So again, we multiply both sides by 40, and we get that y is equal to 40 times the sine of 23, which when you put in your calculator should come out to approximately 15.6 feet. So now I have all of my sides. AB was 40 feet, that was given to me. AC is 36.8 feet. And BC is 15.6 feet. So now I've solved the triangles. I know all the sides and all the angles. Okay, let's take a look at another one of those. We're going to solve this triangle here. And this one is different in that I have two sides and no angles. So for this one, I'm going to use the Pythagorean theorem to find my other side. So a squared plus b squared equals c squared. In this case, 2 squared plus 5 squared equals c squared. And so that ends up being 4 plus 25. And so c squared is 29. And therefore AC would have to be the square root of 29. So I've got this side here now. So I've got all my sides. And now I have to find my other two angles. I know that this one is 90 degrees because it is a right angle. So I'm going to start off with angle C. All right, so the measure of angle C if I look at, I've got the opposite here and the adjacent here, I can use tangents. So the inverse tangent will give me the angle. So the measure of C is going to be the inverse tangent of 2 over 5. And then when you put that in your calculator, you get 21.8. Now I could do the inverse tangent for angle A and find that out, but at this point I already know 2 out of my 3 angles. So you could also just subtract it. So the measure of angle A is just 90 minus that 21.8 we just found. And so that would be 68.2. So those were my missing pieces right there. Okay, and I have one more example here. A real-life example. You're building a track for a model train. You want the track to incline from the first level to the second level 4 inches higher over a distance of 96 inches. Is the angle of elevation going to be less than 3%? So I look at what they've given me relative to my x degrees here. This is adjacent and that's opposite, so I'm going to use the tangent. Tangent of x would be 4 over 96. So I take the inverse tangent of 4 over 96, and that comes out to about 2.4. So is the angle of elevation less than 3? Yes, it is. Okay, so we've got couple more problems for you to try on your own. Start with this one. You're going to solve a right triangle that has a 50-degree angle and a 15-inch hypotenuse and give your answers to the nearest tenth. So I would suggest you draw yourself a picture and then solve for all the angles and all the sides. Pause the video now. Okay, so to solve this, they already gave you the 50 degrees, so it's easy to figure out that the other acute angle has to be 40 degrees. So your angles are 40, 50, and 90. And then for the sides, I set up my triangle the way it's drawn here, and so the sine of 50 would be x over 15, and I end up getting 11.5 for x. And the cosine of 50 would be y over 15. I end up getting 9.6 for y. So your final answer, all your sides and angles, would be right there. All right, here's another one for you to try yourself. Suppose an incline rises 8 inches in 120 inches. Is the incline less than 3 degrees? Pause the video now. All right, so when you solve that one, you would have had the opposite and the adjacent, so you're going to use the inverse tangent. Inverse tangent of 8 over 120 comes out to 3.8, so no, it is not less than 3 inches. And then finally, solve this triangle. Find the missing side and the other missing angles besides the right angle. Pause the video now. Okay, so for your missing side, you could use the Pythagorean theorem. 10 squared plus BC squared equals 26 squared. And you should end up getting that BC is equal to 24. Now use your inverse trig functions to find angle A. So you can use the cosine to find the measure of angle A, and you should get 67.4. And so you can just do 90 minus 67.4, and so the measure of angle C comes out to 22.6 degrees. And if you double check that using the inverse sign, you should get the same answer. And that concludes the video. Thank you.